one such example is you see that the sum of the angles of triangle is 230, not 180, which we say it is 180 in Euclidean geometry. So these are the places where this non-Euclidean geometry is used: cosmology and its geometry, theory of general relativity, and celestial mechanics. Okay, I think let's stop it here. What is the need of it? Okay, sit down. Now, prime numbers, certain properties are satisfied only for those numbers. It is all dependent on the property. For example, when you say even number, it has a property, that is, it is divisible by 2. So such numbers, such a group, we call it as even numbers. Similarly, if you cannot divide by 2, you keep it another group, which we call it as the odd numbers. So it's all depending on the property they are satisfied. Some particular type of property they satisfy. So the similar way, the prime number also, it has got a property, that is, it can't be divided by other numbers other than itself and 1. So it is due to that property we are separating it.
In that manner, we can divide many ways. Then why only that?
Yeah, you can give your name to that. Did you follow it? So you introduce a property. Just tell me one property using which you can make a group. What I am saying is you can give your name to that. Then, like you say prime numbers, we say even numbers, we say. What's your name?
Rajat.
Pardon?
Rajat.
Rajat numbers, we can say. That's what I'm okay. Yeah.
So some mathematical theories derived so far are not. Some of them are really ideal concepts. So when we have the real application of it in practical life, how do you amend the errors which occur there?
Ideal means I don't know.
Which do not have much applications.
Which do not have much application. That's what you mean?
They do have applications.
Yes.
We have many ideal concepts like going into science stream like physics. There are rigid bodies. Now, practically there is no rigid body on our planet, that is Earth. So when we apply that concept in our practical life, then don't we have any errors there?
Actually, what is happening is, in physics, of course, in mathematics, theories are developed. I am a man of physics, naturally. In whatever theories are developed in mathematics, all are not taken into physics. Whatever things can be applied in physics are taken in physics. The rest of them remain in mathematics itself. And then, as an example, suppose aerodynamics or parachute. So first, we don't take all the factors into consideration. We simply take gravity and we derive the formula. But that will not be perfect, as you asked. And afterwards, we add all corrections. Whatever, as an example, buoyancy, air friction, wind velocity, all those things are taken into account afterwards, and finally we get the perfect equation. Initially, if you take all the quantities in terms, whatever factors are affecting, the equation will be too long, we will not be able to solve. We solve with the simple assumptions, and finally we introduce the corrections.
So should we say that the corrections are predefined?
Yes. All those equations, as an example, see that one. Suppose scientists predict that there will be a solar eclipse or lunar eclipse on such and such a particular time. It happens. Means what, the theory is correct, our calculations are correct, application is also correct, there is no mistake. Whatever we are studying is correct only, there is nothing wrong.
Thank you, sir.
Now, as you are aware, there are two theories of gravitation. One is Newton's theory of gravitation. Second is Einstein's theory of gravitation. Now, Newton's theory of gravitation is very simple. It is very simple because that relation says they're actually proportional to product of their mass divided by the square of the distance. That equation is a very simple equation. But you see the equation of Einstein's theory of relativity, there are 16 second order differential equations to solve. 16. At the same time, Newton had only one equation. So why should we make use of the Einstein, such a big 16 second order differential equation to solve that solving one simple equation? Usually both the theorems both the equations are valid, but under strong gravitational field, like neutron star you say, white dwarf we say, and black hole we say, their gravity becomes very important. So there Einstein will be accurate than Newton's. Yeah.
So I have read sources and radius, but black hole radius. I have studied the formula RS is 2gm upon c square. So it gives us the same formula as the escape velocity for a planet. So keeping in mind, we can see is the escape velocity for a black hole, but light doesn't escape the black hole. That doesn't satisfy that condition.
What I know, I will explain to you. In Einstein theory, we have a line element represented by ds square. Like in the usual, if you see that right angle triangle, we have dx square, x square plus y square equal to z square. Now, the similar way we have it in Einstein's theory of relativity, ds square equal to, there is a term with the dx, dy, dz, and dt. The time component also comes into. In that, the coefficient is 1 minus, I am not considering g and c. It is 1 minus 2m divided by r. The term is 1 minus 2m divided by r. Now, it comes in the denominator. That part comes in the denominator. Now, when it becomes 0, that is when 1 is equal to 2m by r. When it becomes 0, then this line element goes out of place. That is the position where that black hole part develops. That is 1 is equal to 2m by r. Or r is, you can say m is equal to r by 2.
In that equation now, c is the velocity of light which we have to take, not the velocity of the particular neutron star. In the case of black hole, there is no velocity. That is not what we have to substitute there. Actual value of c has to be substituted in that equation to get the value.
So, but if we compare the equation with escape velocity equation, we get c as the escape velocity.
But that is the main difference. This escape velocity, as I explained, many terms are omitted because many of the factors are very insignificant. Whereas in the case of high gravity and other thing, we cannot neglect. All the factors are to be taken into equation. That may not give the correct answer when we apply to small planets like Earth.
Gravitation is not that important as far as our part is concerned. When it comes to black hole, it is very important.
Sir, for finding our maximum value or minimum value, we get slope equal to 0, and then we can solve the equation. And if the graph is like 2-3 times parallel to the axis, 2-3 times slope is equal to 0,
Yeah.
then how can we determine the maximum value?
No, when you usually, when you decide the maximum value, what you do is you take the first derivative as 0. Now it is only certain region where you are saying that first derivative should be 0. Now when you, as you said, when there are more than one place, then the equation will give you more than one value. It won't give you just one value, it will give you more than one value. So each value we need to check whether it is representing maximum or minimum. Actually, first derivative equal to 0 does not give you the maximum value. It can be even minimum value also. So those points you get, the values of x you get, then you need to verify for each point whether that point what is that value. Check for the second one, then compare it to get the maximum. Yeah.
So why pi is used in finding area and volume in any other formula? What is in pi? Only pi.
His question was, why pi? Why pi comes in circle, why pi comes in the volume equation? Why pi? Why not something else, the number? What's your name? It. Now the origin of pi is something like this. Now you take a circle, it was the starting part. You take a circle, any circle, as I told you in the earlier, any circle you take, divide with the diameter, that's a constant. That's a constant. Now they are calling this constant as pi. Now this constant, this particular constant, that value we are putting it as the value pi. Which is not, you cannot write it any p by q form or anything. It is an irrational number. It goes 3.1412 and so on it goes. It just never ends. And if it was not pi, then it will be something else. But anyway, there will be that particular number.
It's a very interesting point that when Pythagoras discovered this root 2, the first number that 1 and root 2, first irrational number, then he himself understood at that time the difficulty that these type of numbers are going to create for the future mathematicians. So he called all the students of the academy and there was an oath-taking ceremony. Whatever has been discovered should not be revealed out to the world. So that means he was very well aware that what it is going to create so much of problem for hundreds of future scientists. But afterwards, one of the students disclosed it out. That is why how the world has come to know about this first irrational number root. I have read in an article that even now, even after 2,400 years, there are many famous mathematicians of the opinion that irrational numbers should be eradicated from the number system. Sir, is it possible?
In that case, what will happen is that how do we measure the circumference as is mentioned, it comes in every way, y pi comes in every way. So how do we calculate all such thing? I don't think it is possible. But as I just talked at the real number system. Now there is another number system coming up, which is known as the complex number. What we usually do is we always add. We don't take.
Is there any more question?